So let us start with second lecture of inverse trigonometric function. In the first lecture, I gave you the definition of inverse functions. I taught you what are inverse functions, and then I give you the condition which is required for, I give you the condition for defining inverse of a function. This I give you in the first lecture. That is a function, if you have y equal to f of x, then you can have x equal to f inverse y if and only if this function f is 1 1 and onto 1 1 and onto. I taught you this in detail, and then I taught you that inverse, if you want the inverse of trigonometric functions, then you will have to define the trigonometric functions in the truncated domain. That is, we will reduce their domain. We will reduce the domain, and that you can see in the lecture number 1. So we defined each and every trigonometric functions, like, see, if we have y equal to sine of x, then in order to write x equals to sine inverse y, we need to have some condition fulfilled. Okay, so that I taught you, and I taught you in much detail that if you have y equal to sine x, then how can you write x equals to sine inverse y? Okay, if I have say, if I have here y equal to cos x, then definitely x is equal to cos inverse y, but under some condition. So that condition is required to be fulfilled. So I have taught all these things in last lecture. Now in this lecture, we are starting with the properties of inverse trigonometric functions. So let us begin with properties of inverse trigonometric functions. Properties, let us start with properties of inverse trigonometric functions. Inverse trigonometric functions. Properties of inverse trigonometric functions. So the first one is sine inverse of x is equal to cosec inverse of 1 upon x. Remember this, sine inverse of x is cosec inverse of 1 upon x. Similarly, cos inverse of x is sec inverse of 1 upon x. Cos inverse x is sec inverse 1 upon x. And tan inverse x is equal to cot inverse 1 upon x. So this is first property. See, I want you all to see this from the point of view of relation between trigonometric function. You remember when you had done trigonometric function, there, what was the relation? Okay, see, here you have relation in sine inverse and cosec inverse. But what was it in sine and cosec? Sine of x equals to 1 upon cosec x. See, Sin x is 1 upon cosec x. Okay, so please do not commit a mistake. Do not commit a mistake of writing sine inverse x equals to 1 upon cosec inverse x. Please don't commit this mistake. It is a blunder. It is wrong. What is correct one? Correct one is, see, such a thing, you write the reciprocal when it is trigonometric function. Sin x is 1 upon cosec x. But if it is inverse, then sine inverse x is cosec inverse 1 upon x. Okay. I hope you got this. Sine inverse x is cosec inverse 1 upon x. Cos inverse x is sec inverse 1 upon x. Tan inverse x is cot inverse 1 upon x. Okay, next. Now property number 2. See, what is the second property? Second property here is sine inverse of minus x equals to minus of sine inverse x. Okay, see, in first we have 3. So in the second, see, sine inverse of minus x is minus sine inverse x. Tan inverse of minus x is equal to minus of tan inverse x. It is equal to minus of tan inverse x. And cos inverse of minus x is pi minus cos inverse x. What is cos inverse of minus x? Cos inverse of minus x is pi minus cos inverse x. Okay. Similarly, if you have cosec inverse of minus x, cosec inverse minus x, that is minus cosec inverse x, then cot inverse of minus x, cot inverse minus x is minus of cot inverse x, minus of cot inverse of minus x is pi minus cot inverse x. Okay, what is cot inverse of minus x? It is pi minus cot inverse x, pi minus cot inverse x, and then you have sec inverse of minus x is equal to pi minus sec inverse x, pi minus sec inverse x. These are the properties that you have to learn by heart. These are the properties that you have to learn by heart. Then third. Now third property here is, remember, tan inverse x plus cot inverse x, tan inverse x plus cot inverse x is pi by 2. Tan inverse x plus cot inverse x is pi by 2. Then sec inverse x plus cosec inverse x is pi by 2. And sine inverse x plus cos inverse x is also equal to pi by 2. Okay, this you have to know. Then you have the fourth one, fourth property. See, if you have sine inverse of sine of x, then you will write x. If you have cos inverse of cos of x, you will write x. Tan inverse of tan of x, you will write x. And likewise, etc. Okay. Now property number 5. See, fifth is, see, sine inverse of sine x is x. What happens if I have sine inverse of cos x? See, sine inverse of sine x is x. Cos inverse of cos x is x. But here what I have sine inverse of cos x. So see what I will do. I will write sine inverse of cos of x. You know, this cos x, I will change this to sine. I will change this cos to sine. How? Sine of pi by 2 minus x. What is cos x? Cos x is sine pi by 2 minus x, right? So now what I can write? I can write, now I have sine inverse of sine x. So as I had here sine inverse of sine x, and that I wrote as x. Okay, now what I have? I have sine inverse of sine pi by 2 minus x. So this will become, what will this become? This will become pi by 2 minus x. You understand? So sine inverse of cos x is pi by 2 minus x. So this is sine inverse of cos x is pi by 2 minus x. Same way, look at this. If I have cos inverse of sine x, what it will be? It will be pi by 2 minus x. And if I have tan inverse of cot x, what will that be? It will be pi by 2 minus x. Okay, this way. So remember this. Now property number 6. In sixth property, tan inverse x plus tan inverse y, tan inverse x plus tan inverse y is tan inverse of x plus y upon 1 minus xy. Tan inverse of x plus tan inverse of y is tan inverse of x plus y upon 1 minus xy. When x is greater than 0, y is greater than 0, and x into y is less than 1. X into y is less than 1. Okay. But if you have, see, there is one more result, tan inverse of x plus tan inverse of y, you would be writing pi plus tan inverse x plus y upon 1 minus xy. Tan inverse x plus tan inverse x plus tan inverse y, tan inverse x plus tan inverse y. Here what you wrote? You wrote tan inverse of x plus y upon 1 minus xy. Now here, what are you writing? You are writing same. You can check. You are writing same here once again, but you are adding pi. Okay, see, these two are same. These two are same. This and this are same, but you added pi. Now, why do you add pi? That you have to understand. Tan inverse x plus tan inverse y, why did you add pi? That you have to understand. It is because x is greater than 0, y is greater than 0, and here x into y is greater than 1. Remember, if x into y is greater than 1, then you have to add pi. And in this, there is one you have here. If you have tan inverse of x minus tan inverse y. Now this time you have negative in between. So tan inverse x minus tan inverse y, you will write tan inverse of x minus y upon 1 plus xy. What you will write? You will write tan inverse of x minus y upon 1 plus xy. Now here we have property number 7. See, property number 7 is very much similar to property number 4. Here what you wrote sine inverse of sine x. So you wrote here sine inverse, you wrote inverse outside and trigonometric function inside. Now what we will do, we will write opposite of this. What does that mean? You will know it. Wait. So here I write, see, if I have sine of sine inverse x. So since they are inverse of each other, sine of sine inverse x is x. So sine of sine inverse x is x. Cos of cos inverse x is again x, because cos and cos inverse functions of each other. Similarly, you will have tan of tan inverse x is x. What do we have? We have here trigonometry outside. You can check trigonometry is outside and inverse is inside. Trigo is out, inverse is in. Okay, whereas in that what we had, you remember what you had there? You had there sine inverse of sine x. So you wrote x. There you had inverse outside and trigo inside. Okay. Now check. So then the next one that we have, it will be the eighth one, and see the eighth property is if you have sine of cos inverse x. Okay. So when you had sine of sine inverse x, you wrote it as x. But now what you have, you don't have sine of sine inverse, you have sine of cos inverse x. So let me now teach you that it is, you will write 1 minus x square under square root. It is root of 1 minus x square. Okay. So root of 1 minus x square. So in case if you want that how does it come, I can show you to you. See, the proof is not required, but just for the sake of your comfort, I can show it to you very fast. Let me have, see, I want to prove this, right? I want to prove this. So see, how do I prove it? I will write let cos inverse of x equals to y. Let me have cos inverse of x as y. This I am writing as y. Okay. So if I am writing this as y, so now I understand that what I should now be finding sine y. See, if I am taking this as y, if this is y, it means this whole thing is nothing but sine y. Okay, so I have to work for now sine y. Got it? So see here, x is equal to cos y. Cos inverse x is y, so x is cos y. I square both sides, so x square is cos square y. Therefore, x square is 1 minus sine square y. Okay, because cos square y is 1 minus sine square y. Now sine square y I shift on the left. So I have therefore sine square y as 1 minus x square. 1 minus x square. Therefore, I have sine of y as square root of 1 minus x square. What is sine y? Square root of 1 minus x square. And what is y here? Y is cos inverse of x. Y is cos inverse of x. So you have sine of cos inverse x is equal to square root of 1 minus x square. Sine of cos inverse x is square root of 1 minus x square. So I just proved this for you. Similarly, listen, if you have cos of sine inverse x, you will write here, once again you will write 1 root of 1 minus x square. Root of 1 minus x square you will write even for this. Remember these two are very important. You will remember them as well. Now this completes the properties of inverse trigonometric functions. Very soon now we will start with the problem solving. So now we are starting with problem solving, and here we have, so we have here exercise 3.3, first question, find the principal values of the following. Now see, what is meaning of finding principal values of the following? You have 6 questions here. You have to find the principal value. So first of all, I will explain you what is meaning of find the principal value. So see here. Okay, I want your attention. I want your attention. This part is very, very, very important. Okay, now you having understood what I am now explaining, it will make you very confident in the whole topic. See, as you all know, students, that sine of pi by 6, if I write sine of pi by 6, that is sine of 30 degree. So sine of pi by 6 is 1 by 2, right? Sine of pi by 6 is 1 by 2. So what is pi by 6? It is sine inverse of 1 by 2. Okay, sine inverse of 1 by 2. So just see here that sine inverse of 1 by 2 is equal to pi by 6. Sine inverse of 1 by 2 is equal to pi by 6. What is sine inverse of 1 by 2? Sine inverse of 1 by 2 is an angle. It is an angle. And what is that angle? That angle is pi by 6. Sine inverse of 1 by 2 is equal to pi by 6. Sine inverse of 1 by 2 is equal to pi by 6. But for your kind information, look at this. If I write sine of, if I write sine of 5 pi by 6, sine of 5 pi by 6. Sine of 5 pi by 6 is how much? This is sine of 5 times pi by 6, 150 degrees. Sine of 150 degrees. Now sine of 150 degrees, if you do not remember, I will find it for you. Let me find it out. So sine of 150 degree, I can write 180 minus 30 degree. 150, I can write 180 minus 30. And now you know, if you have 180, then the trigonometric ratio will not change. If you have here 180 minus theta, the trigonometric ratio doesn't change. It changes only when you have here odd multiple of 90 degree. This is 2 times 90 degree. So trigonometric ratio will not change. So what you will have, since it is 180 minus theta, this will remain sine. It will remain sine, and here you have 30 degree. Moreover, this is in second quadrant. Now you know, in second quadrant, if you have an angle in second quadrant, for such angle, sine is positive. So sine for 180 minus 30 degree, sine for 180 minus 30 degree is positive. So here it is positive. Okay. Now what is this sine 30 degree? Sine 30 degree is 1 by 2. So what I wanted to tell you is, here you have sine of 5 pi by 6. Sine 5 pi by 6 is also 1 by 2. So check, what was sine pi by 6? Sine pi by 6 is 1 by 2. And sine 5 pi by 6 is also 1 by 2. So if sine 5 pi by 6 is also 1 by 2, I can always write 5 pi by 6 is sine inverse of 1 by 2. I can always write this way also. You understand? If sine of 5 pi by 6 is 1 by 2, definitely 5 pi by 6 is sine inverse of 1 by 2. So now the difficulty here is that you have sine inverse of 1 by 2 here. If you see this, then you have answer as 5 pi by 6. You see this? Here you have 5 pi by 6. But if you have sine inverse of 1 by 2 here, it is pi by 6. It is pi by 6. And the basic rule in function is you cannot have two values for sine inverse 1 by 2. It has to be either this or this. Remember, so we have defined it in such a way that this one we will call it as principal value. Remember students, this is known as principal value. Okay, what we will do, we will discard. See, this is correct, no doubt it is correct, but we will discard this because it is not principal value. It is not principal value. Sine inverse 1 by 2 is 5 pi by 6. Remember, as you got sine 5 pi by 6, sine 5 pi by 6 as 1 by 2, there are infinitely many angles for which sine value will be 1 by 2. Remember that. There will be infinitely many angles for which sine value is 1 by 2. So in that case, sine inverse 1 by 2, in that case, sine inverse 1 by 2 will also be infinite values here. You understand? Like you have 5 pi by 6, you can have here 2 pi plus pi by 6. That is, you can have here 2 pi plus pi by 6. Now, how much is 2 pi plus pi by 6? It is 13 pi by 6. So sine inverse of 1 by 2 can also be 13 pi by 6. Okay. See, this is also correct. You can't say it is wrong, but then it is discarded because it cannot be accepted. How can you accept sine inverse of 1 by 2 as more than one value? That will not let your calculation happen. So we have defined it in such a way that if we have sine inverse of 1 by 2, then the value will always be in between minus pi by 2 and pi by 2. Okay, so now I define that here. See, so after having found, remember, so if someone asks me sine inverse of 1 by 2, check. See, now keep listening to this. See, suppose someone asks me sine inverse of 1 by 2, okay, the principal value. Someone asks me the principal value. So what I will do is immediately I will recall my definition. What was the definition? You remember? If x equals to sine y, if x equals to sine y, then y equal to sine inverse of x, y equals to sine inverse of x, and what was y was in between minus pi by 2 to pi by 2. Remember, y was in between, that is the sine inverse x value. You see this, you are writing y, that is the angle part, that is the angle part. Where is the angle part? It has to be in between minus pi by 2 and pi by 2. That is sine inverse x value, which is y, it has to be always in between minus pi by 2 and pi by 2. That is, it has to be always in between these two quadrants, minus pi by 2 to pi by 2. So here what I found, sine inverse 1 by 2. Sine inverse 1 by 2, I will write pi by 6. And then immediately I will check the answer which I get, the answer which I get, the answer which I get, is this answer in this? So pi by 6 is here. So my answer is correct. Okay. So you will have to follow this in order to write the correct answer. So let me begin now writing the answer. I hope you understood whatever I explained. So I will begin with the answer. The answer is sine inverse of 1 by 2. Sine inverse of 1 by 2. Okay. So what I will write, see here, sine inverse of 1 by 2. See, this is very simple. This is very simple. You should first understand that sine inverse of 1 by 2 is an angle. What is this? It is an angle. I repeat, what is this? This whole thing is an angle. It is an angle. You don't believe it? Check this. What is sine pi by 6? Sine pi by 6 is 1 by 2. Now tell me, what is pi by 6? Is it not an angle? Yes, it is an angle. So as you have pi by 6 angle, the next step, wouldn't you write pi by 6 as sine inverse 1 by 2? So what is sine inverse 1 by 2? It is pi by 6, which is an angle. So this is an angle. Sine inverse of 1 by 2 is an angle. Which angle? It is the angle for which sine value is 1 by 2. It is the angle for which sine value is 1 by 2. And what is that angle? The angle is pi by 6. The angle is pi by 6. So here I write, see here, let me start writing the first one. The first one is sine inverse of 1 by 2. Okay. See, now I tell you the technique to write the answer. See how you have to write sine inverse of 1 by 2. So see, you begin writing like this. Let sine inverse of 1 by 2, okay, equals to y. Okay, so remember y is the angle whose value you want. So therefore 1 by 2 equals to sine y. 1 by 2 equals to sine y. Now remember, the moment you wrote this, what are you doing? You are defining the inverse function. So you will immediately write where you wrote sine inverse of 1 by 2 as y. So what you will write, where y is greater than equal to minus pi by 2, greater than equal to minus pi by 2, and lesser than equal to pi by 2. Okay, y is greater than equal to minus pi by 2, greater than equal to minus pi by 2, and lesser than equal to pi by 2. You understand? So now you will now see you have here sine y as 1 by 2. So this implies what? Therefore y equals to pi by 6. Okay, y equals to pi by 6. Come on, you know sine y 1 by 2, so y has to be pi by 6. Sine of y, this we had been doing for last 3-4 years. Sine of y is 1 by 2. If what is y such that we get 1 by 2? Sine y, what should be y should be 30 degree, that is pi by 6. So I got y as pi by 6. And what was y we had assumed to be sine inverse of 1 by 2. So this implies sine inverse of 1 by 2 is pi by 6. We got the answer. Okay, let me take one more that will explain you. See, it is very simple. It is only you have to learn to write the answer. It's very simple. It's very, very, very simple. Okay. Now I go for the second one. Uh, yeah. So here I write the answer number. Hmm. Yeah. Let me write second. Yes. So second is cosec inverse 2. You know what I'll write? I will write here, let cosec inverse 2 equals to y. Now see, cosec inverse 2, you know, it is same as sine inverse of 1 by 2. See, what is cosec inverse 2? Cosec inverse 2 is sine inverse of 1 by 2. Yes, we know the result. Which result we are using? Which property we are using? Sine inverse of x is cosec inverse of 1 by x. So cosec inverse 2 is sine inverse of 1 by 2. And after this, what I will do? After this, I will write exactly what I wrote here. See, after this, I will write this part exactly same, and we will get the answer. So this one you can solve. You can solve after this. Okay. Let me now take the fourth one. I will solve the fourth one, so you can solve the third one. See the fourth one, how I solve. This is tan inverse of minus root 3. Okay, so the fourth one is, this is tan inverse of minus root 3. Okay, so I will write here tan inverse of minus root 3. So that is equal to, I write here, we know that tan inverse of minus root 3, tan inverse of minus root 3 is equal to minus of tan inverse root 3. Okay, which result? Tan inverse of minus x is minus of tan inverse x. So tan inverse of minus root 3 is minus of tan inverse root 3. And then I write this as 1. You got it? Now what I will do? I will take this as y. See, let me now take this as y. Okay, I will take tan inverse of root 3 as y. So I will write here, let tan inverse of root 3 equals to y. Therefore root 3 is tan y. Okay, and what did I do here? I applied the inverse trigonometric function definition. Now remember, if you could write this, it is not always possible. Tan inverse of root 3, if you are writing, tan inverse of root 3 is y. If you are writing root 3 as tan of y, then the condition needs to be fulfilled. What the condition is? Where you remember this angle has to be truncated angle, where y is greater than minus pi by 2 and lesser than pi by 2. Y is in between minus pi by 2 and pi by 2, right? And See, it is same as sine inverse. As you define sine inverse, for tan inverse, the angle is same. And the only thing is that equal to is not there. Why? Because tan minus pi by 2 and tan pi by 2 is not defined. So now you tell me, if you see tan of y as root 3, tan of y as root 3, what could y be? Therefore, y equals to pi by 3. Okay, you got y as pi by 3, and this implies what was y you had assumed? You had assumed y to be tan inverse root 3. So this implies tan inverse of root 3 equals to pi by 3. See, I got this answer, and immediately the moment I get the answer for tan inverse of root 3, I would check whether I'm getting it in the given interval. It has to be, the value of tan inverse root 3 has to be in this interval, that is minus pi by 2 to pi by 2. And where am I getting? I'm getting pi by 3. It is correct answer. It is correct answer. Remember, as such, there are infinite values for tan inverse root 3. There are infinite angles for which tan value can be root 3. Okay, but we want only pi by 3 because this is principal value. So now what will happen? Now, so tan inverse of minus root 3, I will use this in 1. I write this as 2, and now I write using 2 in 1. We get what we get. We will get tan inverse of minus root 3 equals to minus of pi by 3. What we will get? See, tan inverse of root 3, which is pi by 3. So I substitute here pi by 3. So minus of pi by 3. This is what I will get. So as I solved the fourth one, tan inverse of minus root 3, you all can solve the third one, tan inverse of minus 1. This you can solve. This you can solve. The answer will be minus pi by 4 for this. Okay, and answer for this will be pi by 4. Sine inverse of 1 by root 2 will be pi by 4. You can solve this. I take the sixth one, which is cos inverse of minus 1 by 2. Let me solve the sixth one. So sixth is to find cos inverse of minus 1 by 2. So see, how do I find cos inverse of minus 1 by 2? The first thing I will write is, we know that cos inverse of minus x is pi minus cos inverse x. Okay, this you will write first. Always, if you have inverse trigonometric function of a negative number, you will first change it to positive number. Okay, you saw even for tan inverse minus x, I wrote minus tan inverse x. Cos inverse of minus x is pi minus cos inverse x. So here I have cos inverse of, therefore cos inverse of minus 1 by 2 will be pi minus cos inverse of 1 by 2. Okay, and this is my 1. Now what is my aim? My aim is to find cos inverse 1 by 2. I will find out the principal value of cos inverse 1 by 2. Okay, as such, what is meaning of cos inverse 1 by 2? Okay, what is meaning of cos inverse 1 by 2? If I ask you what is cos inverse, what does cos inverse 1 by 2 mean? Remember students, this is an angle. It simply means an angle for which cos value is 1 by 2. Cos inverse 1 by 2 is nothing but an angle. It is an angle for which cos value is 1 by 2. And you know one angle you all remember, which is pi by 3. Cos pi by 3 is 1 by 2. But remember, like pi by 3, there are infinite angles for which cos value will be 1 by 2. There are infinite angles. Okay, cos minus pi by 3 is also 1 by 2. Then cos of 2 pi plus pi by 3 is also 2 pi plus pi by 3. This is also 1 by 2. So for all this, If cos pi by 3 is 1 by 2, what is cos inverse 1 by 2? Pi by 3. What is cos inverse 1 by 2 here? Minus pi by 3. What is cos inverse 1 by 2 here? 7 pi by 3. Like this, cos inverse 1 by 2, there are so many answers. There are so many values. But you know what? We have to find the principal value. We have to find the principal value. And how do we get the principal value? It is based on the definition. So here we will start with the definition. See, how do I write? I will take this as y. Okay. I will assume this to be y, and y is my angle. So here I'll write, let cos inverse of 1 by 2 equals to y. Therefore, 1 by 2 is cos y. Okay, and remember, when you are defining this way, it means you are defining the inverse of cos. And if inverse of cos is defined, then this angle has to be in between 0 and pi. So you will write where y is greater than equal to 0 and lesser than equal to pi. Okay, where y is greater than equal to 0 and lesser than equal to pi. Okay, so 1 by 2 is cos y. Now the moment I write 1 by 2 as cos y, I know what could y be. I know the value of y such that cos of that y is 1 by 2. I will write therefore y equals to pi by 3. And further, now see, y is pi by 3 I got. Now tell me, when you write y as pi by 3, you will have to check what is this value of y in between 0 and pi? The answer is yes. If it is in between this, it is the principal value you got. Okay. So this implies, see, y you got pi by 3 and this y was nothing but cos inverse 1 by 2. So you got cos inverse of 1 by 2 as pi by 3. Okay, this is number 2. What you will do? You will substitute this 2 in 1, because remember the question was cos inverse negative half. You have found cos inverse positive half. Okay, so you will write using 2 in 1. Using 2 in 1, we get what you will get here cos inverse of, you will get here cos inverse of minus 1 by 2 equals to pi minus pi by 3. Pi minus pi by 3. That is equal to 2 pi by 3. What is the answer? Pi minus pi by 3 is 2 pi by 3. So you got the final answer as, so here I'll write the final answer. Therefore, cos inverse of minus 1 by 2 is 2 pi by 3. You can copy this. So now we take question number 2. We take question number 2 in which we have to evaluate the following. Okay, so to evaluate means to find the value. So we have these 4 questions. I shall be solving one by one. Very simple problems these are. Let's begin with the evaluation. So let me start with the first one. I'll write the answer for the first one. The answer for the first one. See what I have. I have here tan inverse of 1. See, to evaluate what? Tan inverse of 1 plus cos inverse of half plus sine inverse of half. You see this? Now, see, tan inverse of 1. I have already told you all that inverse trigonometric function of a number is an angle. See, this is an angle. Which angle? It is that angle for which tan value will be 1. It is that angle for which tan value will be equal to 1. Tan value will be equal to 1, and that is pi by 4. You know, tan pi by 4 is 1. So you write the principal value. Remember, you will have to write the principal value for all. Then you come here. Then you see this. Cos inverse of 1 by 2. Nothing but an angle. Which angle? It is that angle for which, the cos value the cos value is 1 by 2. It is the angle for which cos value is 1 by 2. Which angle? The angle for which cos value is 1 by 2. So you know cos of pi by 3 is 1 by 2. So cos inverse of 1 by 2 is pi by 3. What is cos inverse of 1 by 2? It is an angle. The angle, this whole thing is an angle. Remember, this is whole thing is an angle. Which angle? It is the angle for which cos value is 1 by 2. See, cos pi by 3 is 1 by 2. So what I will do here, I shall now be evaluating this. So, but I notice something here. I notice something here. I note that I have got cos inverse of 1 by 2 plus sin inverse of 1 by 2. So see the very next step. This is tan inverse of 1 is pi by 4 because tan pi by 4 is 1 and this is principal value. Why? Because this value is in between minus pi by 2 and pi by 2 plus cos inverse x plus tan inverse x is pi by 2. See, this is pi by 2. This whole thing, please, this whole thing is pi by 2. Cos inverse of x plus sin inverse of x is pi by 2. So what is the answer now? This is pi by 4. This is 2 pi by 4. So this is 3 pi by 4. So the final answer is 3 pi by 4. You can write here, if you want, you can write here using since sine inverse of x plus cos inverse of x equals to pi by 2. So we have done the first one. The answer is 3 pi by 4. Okay. Now we take the second question. See, the second question here I have is, look at the second one. Second is to evaluate. The first one is over. The second one is to evaluate cos inverse of 1 by 2 plus 2 times sine inverse of 1 by 2. You know what I will do? Next step. Next step, I will write this as cos inverse 1 by 2 plus, this is 2 times sine inverse 1 by 2. So I can write this as sine inverse 1 by 2 plus sine inverse 1 by 2. Okay. And then after this, as you know, cos inverse 1 by 2 plus sine inverse 1 by 2 will be pi by 2. If you have these two numbers same, remember, if you have these numbers same, then sine inverse plus sine inverse of this number plus cos inverse of same number is pi by 2. Okay, so this whole thing is pi by 2. So here I write equal to pi by 2 plus, now this thing, what is this? It is the angle for which sine value is 1 by 2, and that angle is pi by 6, and it is principal value pi by 6. So the final answer here is, this is pi by 2 plus pi by 6. This is 3 up and 3 down, so 3 pi by 6. We got here 4 pi by 6. Okay, this is 3 pi by 6, 4 pi by 6. 6 is the LCM, 4 pi by 6. That is 2 pi by 3 is the answer. What's the answer here? The answer here is 2. Now I solve the third one, that is tan inverse of root 3 plus sec inverse of minus root 2. So the third one is, to evaluate tan inverse of root 3 plus sec inverse of, it is minus not plus, so here it's minus. This is negative minus sec inverse of minus 2. We have to evaluate this. Okay, see what I will do. The next step, the very next step, I write tan inverse of root 3 and sec inverse of minus 2. As I told you, if I have a negative number here, I would first try to write it as positive number. So the next is minus, and then I write pi minus sec inverse of 2. How? Because we know that since sec inverse of minus x is pi minus sec inverse x. Okay, so I write this. Now, what is tan inverse of root 3? We know it is an angle. This is an angle. This one is also an angle. Okay, so which angle is this? Which angle is this? Tan inverse of root 3 is the angle for which tan value is root 3. This is pi by 3 minus okay, and then pi minus sec inverse 2. It is an angle. Which angle? The angle for which sec value is 2. Okay, so cos, see, sec inverse 2, you can write it as cos inverse of 1 by 2. Okay, now you know what will happen. Pi by 3 minus pi minus cos inverse 1 by 2 is pi by 3. Cos inverse 1 by 2 is pi by 3. How? Because cos pi by 3 is 1 by 2. See how interesting this is. How interesting this is. That, see, here you have trigonometric function. This is trigonometric function, cos. So remember that the domain of trigonometric function is an angle. What you have with cos, how interesting. What you have with cos is an angle. This is angle. But what you have with cos inverse, now see, you have cos inverse 1 by 2. Cos pi by 3 is 1 by 2. So cos inverse 1 by 2 is pi by 3. Now what you have with cos inverse, this is not angle. Instead, the whole thing is angle. The whole thing is angle. You got it? So cos of 1 by 2 is pi by 3. That is it. So now you open this and you will get pi by 3 minus pi plus pi by 3. That is equal to 2 pi by 3 minus pi. That is equal to minus pi by 3. So you will get the answer as minus pi by 3. You can copy this. Now we have the fourth and the last for today's lecture. Okay, we have done these three. Now I'm doing the fourth one. I'm now solving this one. Okay, this one is also quite easy. What is it? It is cosec inverse negative root 2 plus cot inverse root 3. So the next step, as I told you, I will first try to convert this number to a positive number. So what is the property? Cosec inverse minus x is minus of cosec inverse x. So this is minus of cosec inverse root 2 and plus cot inverse root 3. The next step is I will write minus, and this cosec inverse I will convert it to sine inverse. So this is sine inverse of 1 by root 2 plus cot inverse of root 3 is tan inverse of 1 by root 3. Now I know these values. See, I know these values, the principal values. Sine inverse of 1 by root 2. This is an angle. Which angle? Pi by 4. Tan inverse of 1 by root 3 is also an angle. Which angle? Pi by 6. So I have minus pi by 4 plus pi by 6. Minus pi by 4 plus pi by 6. So the LCM here is 12. 12 is the LCM. I get here minus 3 pi plus 2 pi. Minus 3 pi plus 2 pi. Okay. That is equal to minus pi by 12. This is what I get. I get answer as minus pi by 12. I hope you all have understood. Good luck. See both the videos. See the first video and also see the second video. Okay, remember, if you want to learn inverse trigonometric functions well, you will have to learn the basics. That is, basics are given in the first video. Okay, and that is very simple. Very simple. It is only that 1 1 on 2 is required. So for 1 1 on 2, what we do is we truncate the domain of trigonometric functions so that the trigonometric functions, which are many to many into functions, They become one-to-one onto functions. Okay, see the first video, see the second video. This is the end of this lecture. The next lecture will be the last lecture on inverse trigonometric functions.